300 million years ago, insects reached the size of modern vehicles. This scale was a direct physiological response to Earth's atmospheric chemistry. This chart contrasts modern atmospheric limits with the Carboniferous period. Our current 21% oxygen level acts as a mechanical governor, while the prehistoric 35% anomaly removed the primary barrier to massive growth. Physical evidence in the fossil record confirms this scale. Preserved wing veins of prehistoric dragonflies show wingspans matching the reach of a human arm. These monstrous proportions were the result of a hyper-oxygenated environment that essentially weaponized insect biology, allowing them to bypass the gas exchange limits that keep modern bugs small. Insects lack active lungs, relying instead on passive portals called spiracles to draw air into internal tubes. In a 35% oxygen atmosphere, pressure pushes oxygen so deep it becomes toxic. To avoid lethal oxidative stress, insects increased their mass, diluting the oxygen's reach. These levels were sustained by massive prehistoric swamp forests. This dense carboniferous flora acted as oxygen factories, saturating the atmosphere and maintaining the high-pressure environment. Gigantism was a physiological necessity for survival. Growing larger allowed these organisms to safely regulate the flood of high-pressure oxygen that would have otherwise damaged their internal tissues. This graph tracks the drying event that destroyed the ancient forests. Oxygen levels crashed, dropping from 35% to 21%. Simultaneously, this secondary line tracks the rise of early avian species. As the air thinned, agile birds dominated the sky. These skeletal structures confirm the arrival of agile, warm-blooded hunters. The massive insects, already struggling to breathe in the thinning atmosphere, became slow, easy targets. Survival required a total biological retreat. Rapid miniaturization allowed insects to operate on less oxygen and hide from the new aerial predators. Modern insect size represents a calculated evolutionary compromise. Miniaturization allowed these species to persist within a restricted oxygen environment while evading extinction. Modern insects are the genetically reduced remnants of prehistoric apex predators, operating at a fraction of their potential scale. Their current anatomy is optimized for efficiency within our thin atmosphere. These delicate wing structures function at the 21% oxygen limit. If Earth's atmospheric chemistry ever reverts to a hyper-oxygenated state, the mechanical barriers to their growth will vanish. The prehistoric potential for gigantism remains coded into their biology. It simply waits for a shift in the air we breathe.